Hi, this is Learning Programming in Java, Functional Programming. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. Hey, we don't have a lot of money, so I'm going to recommend some, I think, the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, and programming, his style, his wording, it really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. How you doing? So let's talk about functional programming in Java. Let's be clear on the distinctions. Functional programming by itself is a programming paradigm treating computation as the evaluation of mathematical functions, and it avoids changing state. It's immutable. We like that. Now, Java introduced functional programming through lambdas and streams, and we'll see examples of that. But these are not the same thing, all right? A lambda is an implementation of functional programming, so are streams. But Java in itself is not a language based on functional programming. It incorporates it. There are some languages that only do functional programming. Java is not one of those. If you're doing React or Angular development on the front end, you'll probably see a lot of you'll see a lot of things that look similar. So let's talk about these things and see how Java has incorporated functional programming. So why are we doing functional programming? Code is cleaner, easier to write parallel code with the Stream API. We really like the less side effects. Things are immutable, so they're more predictable. We like the reusability that we're using. Contracts of lambdas and streams promote reusable logic. All right, so because we know that Java is not a purely functional language, there are ways to mutate and make state changes. These features, though, allow the developer to write cleaner, more efficient, and expressive code. If you're a legacy programmer, this will be new to you, and you're just going to have to learn it. It takes a while, but once you get the hang of it, I think it all works out. All right, I do want to emphasize this. Lambdas do allow concise function-like behavior. All right, you write code with the least amount of syntax, which can throw some people off. It threw me off. That seems like it's too minimal. All right, that syntax can be maddening at times. It is like, what is going on? It's a little difficult to debug. But this programming style does take some time to appreciate. But once you get the hang of it, it does lead to more efficient code, and it really is the way going forward. That's the way Java is going. So you really should need to pick it up. Okay, we always like examples. So compare these two functions, these two pieces of code. The array list is always going to be there. All right, so we have a list of integers. We're going to call it numbers, 1, 2, 3, 4. But look at how the lambda, which is built into the list class, look how it does a for loop. It can do a for each. The n is the variable. Compare that to the line below, where there's a for loop and you declare an integer and give it a name of n. So that's the same. The finger, or the dash and the arrow, sometimes called the finger, that's new to you. And we're going to pass that end, which is part of the for, and we're going to give it to the systemout.println, and then multiply it by 2, and then systemout is going to print out the result. That is the equivalent to the for loop underneath that. So look at what we got rid of. We don't have to declare an n. We don't have to do the curly braces. We can do it all inside the function itself. We're still calling system.out, but you can call what you need as long as it doesn't change the data. N times 2 doesn't change n, it just prints it out. So if you need to take a second to look at the two, do a little mapping in there. All right, compare that the n up here is the equivalent to the n down here. This system.out is this system.out, and we're always referring to this numbers array. So here's numbers, but where's numbers here? It's not. It's more concise. This is kind of the comparison between the two. We're going to have to get used to this. The old way is going to have to give way to the new way, and this is the way that Java is going. Okay, I just showed you an example of a lambda. What if I made it even less code, quote unquote cleaner? Check out my for each loop. Okay, what's going on here? All I see is a system.out and a print line, and where's the parameter? What happened to my n? Okay, I used to have an n here, and then I would pass it into print line, but you don't need it. Okay, because lambdas will use a little shorthand where a method can be referenced by the name. Okay, so I don't need to declare name. It can just assume that whatever the variable that it's generating will be passed to print line as long as it's the correct type. So name has been removed. You could have done the below down here, but you don't, okay? Because this name is going to be passed in here. That's redundant. You can just use this shorthand. So previously I showed you migration to lambdas that did cut out some of the for loop. Now I'm showing you even more concise syntax. You may have to refer back to this slide for the next slides, but this is the basic syntax, okay? In terms of the arguments, they're going to be followed by the finger, or also known as produces. It's followed by the method body. Now, if you only have one argument, like the n or the name, then you can skip it. You don't need to restate it. The best practice is to use parentheses around the arguments, okay? When there are no arguments, here's a trick one. You must use the parentheses to indicate an empty argument. So if the logic isn't using an argument, or isn't passing an argument, is just looping, for example, then you need to do the parentheses to indicate that, hey, there's nothing in here. So that's how you tell it that there are no arguments to pass. In terms of multiple arguments, you have to use a parameterized argument list. So let's see some examples of all this, but this is the basic construct. Okay, we want the data coming back to the lambda, right? So what happens next is the lack of a return when you only have a single line. That's brevity, right? We don't need to do return if it's only one line. We just can assume that it's returning. When we have multiple lines though, we can't assume that. We'll do the little curly braces and we'll bring back the return. So for single lines, return is not necessary. For multiple lines, we go back to the curly braces and the return. Okay, hold on to your hats. Let's buckle up. Let's take this step by step. All right. So we're going to use some arguments here, some examples. What I want you to focus on is not the interface itself, okay, but this argument is empty. This argument 1 over here is of type string. This one takes two arguments, a string and a double. So we're going to start with these, and these interfaces have a single method, and each method has a different set of arguments, and we're going to use this in next to kind of show you how we can use these lambda functions. All right, so keep that in mind. If you need to scroll back to this slide, let's do that, but this is the reference. All right, let's keep building here. So now I have a reference to that interface. And so that way we can do something with this so you can see it a little bit more. Here's my single argument. All right, I'm going to add this string to an argument that you pass into me. So this is the argument h. This is a single arg. And if we remember that this function took in a string, and I'm going to take the string that you pass into me and I'm going to add no parentheses to it. Just to show you that you can also do the parentheses around the argument, the matter of style, personally, I like this one a little bit better. Even though I could use this one without the parentheses, I like putting the parentheses around me. Maybe I'm old school, but this one I like better. These two are equivalent. So these two are referring to the same interface over here, okay? That takes in a single string argument. These are the same. This one is without the parentheses, and the one below it has parentheses. All right, so let's pause there. Okay, so these two up here, 1 and 2, are the same. I'm taking in whatever you give me as a parameter, and I'm going to add these strings to it. All right, hold on. You're like, I still don't get it. All right, so for in the previous slide we had a declaration. Here we're going to do something with that function declaration. All right. If you recall, with the ones that had 2 arguments, here's my implementation. I'm going to add the string and the double. And you know, in Java, if you start with a string and add a number to it, it will automatically convert the type. All right. What about the one that has no arguments? Remember, I said when you have no arguments, you need the parentheses. You see why now? Because without it, you wouldn't have anything here to declare that there's no arguments. You have to show that there's no arguments to declare there's no arguments. But in this case, I'm going to, if you don't give any arguments, I'm always just going to tack on this string. Okay, that's what I'm going to do. If you recall, in this one with the multiple lines in the body, all right. If you go back to that interface and look at that one, here I have the curly braces again, like I used to. That's cool. This is multiple lines, so here I have to have the return. The ones up here, no return. The return is implied. But when I have multiple lines, all right, I need the curly braces and the return. Over here, I can do it all in one line. I don't need the curly braces or the return. Same up here. I don't need the curly braces. I don't need the curly braces here or the return. I can just live without it. But for this one, I have 2 functions, things happening. I have a system.out, and then I'm returning this string. So that's 2 lines of code. So now I need the curly braces and the return statement. Okay, so let's do something with these interfaces and implementations. All right. Remember with this one, body no arg. There's no argument in here, okay? But we decided that over here, if I implement the body no args and I give it this name, all right, this says, right, remember, no parameters being passed in. I'm just always going to tack on this string. So if I invoke this lambda right over here, so if I invoke the lambda, the brief is up here, that's this. What's going to happen? There's no parameters, so that, I'm not passing in a string. The lambda is just going to print out this string. I did this so that you could see it do something. Otherwise, the output would be empty. Like I don't see it do anything. So I could have just done some computation, or I could have done some algorithm. But I wanted to show it printing a string, and in the lab this will make a little more sense. So you can see that it did something. It actually evoked something. Okay, that this actually executed. All right, even though there's no parameters, this is always just going to print out. Okay, now we're getting more complicated. Then we move down to the next interface. This is the body with a single argument. So I'm taking in a string. All right. So let me declare an instance of that interface, static. And that argument that you pass in to me, I'm going to take that argument and I'm going to add this statement. Remember I showed you that you can have the parentheses and not the parentheses. So here's the same line, body with a string argument, same type. Okay, these are the same type, but I have a different instance of it. This one has parentheses. Style-wise, I like this one better. But this time, when you give me when you pass in a parameter type string, I'm gonna add this phrase. Okay, these are 2 different phrases. I could have made them the same, but then you wouldn't have noticed the difference. So now let's actually invoke them. All right, so here's body, single argument. I'm passing in a parameter, you remember the logic? Parameter plus this guy. Boom, I get this. Now this other lambda, I give it its own parameter. Remember the logic was take the parameter and add this string. And that's this output. Pause here, step through this. It took me a while to put the slide together, but if it helps, kind of step through the code, all right? One step at a time. Okay, now we're getting a little more complicated. So remember the previous interface body with multiple arguments, a string and a double? We said that implementation, all right, was to add the string and the double that you pass into me. So let's do that now. So let's take this string and this number that I pass into over here. What do I get? There's the string that I gave you. That's the number, and that's my output. Okay, so this is the implementation. This is the interface, a string and a double. And here I am invoking that with a string and a double. Got it? Okay, let's keep going. Okay, we're not done yet. We can keep going. Now I showed you how to do those lambdas with different parameters in the interface. I can also have method references. A method reference is a class name or an object name followed by the colon, and then the name of the method. It's a shorthand notation, okay, for lambda expressions to call a method. Remember the conciseness and making it smaller. It makes it easier for readability, conciseness. Some of you may disagree, like, oh, this is more confusing, but once you get used to it, then you realize, hey, this is even less code I have to maintain. Okay, let's keep going. I have a reference, and I've called it callable. It has a method called call, and this is the important part. It has a interface that takes in a string, just one argument. Okay, so keep this in mind, and let's see what happens next. Okay, so we had those little interfaces. Now we're going to create a class, discuss. Here's the constructor that takes in a string. We'll see that next. But this is what I want to focus on. So this class method has the same signature as the callable interface. Remember, it had call that takes in a string. This is a different function, different method in a class. And here's the implementation. Okay, so bear with me here. So previously I had an interface, I had a definition. Okay, here I have a class that has a function with some implementation in it, and it has the same signature. All right, so these match up. So let's see what we can do with this. Okay, did you buckle up? Hold on, here we go. I'm going to create an instance of this class with its required string constructor. We don't need that right now, but I have an instance of discuss. I'm going to assign the instance methods, the method of this instance, to the callable interface. Why does this work? Why does this compile? Okay, here's my little lambda construct, the colon. This is telling me that this is a method, and I'm going to assign it to this interface. They both took in a string as a single parameter, so they are the same when we are equating methods. They may have different names, but they have the same signature. Now that I have assigned this implementation to this interface, remember callable didn't have an implementation. I just like, hey, I take in a string, I take in a single string, that's my interface. Here's an actual class at runtime. I instantiated this class. Here's a method that matches that interface. Now that interface can call with a parameter, remember that single string, but it's not calling itself. It's not calling an interface. You can't instantiate an interface, but the interface can call the method that it has been instantiated with. This is kind of like assigning a variable, but you're assigning a method to an interface. you can now invoke this guy through this interface, because Java maps call to my amongst ourselves interface because they are the same signature. Whoa. Hold on to that. Let's keep going. Now you're probably saying to yourself, why did I go through all that? That seems kind of like madness. All right. I assigned an implementation, that implementation being a method in and of itself, to this interface in callable. And then I just called it. Why did I go through those loops just to call the same method? Because I can change the variable implementation at runtime. I can say, now, C has this whole other method. This, by the way, this say hello takes in just a string. Same interface. Now, if I call that, I'm going to call this method that I have defined that takes in a single string. So now I'm changing out this implementation. This method had an implementation. Now I want to give you a different implementation, but with the same interface. So if you remember the whole discussion about polymorphism and interfaces, so I can change out my implementation as long as I adhere to the interface. The interface is defined in callable, which is a method with a single argument of type string. So now I've changed implementation by changing the methods. Before I had a method assigned to this discuss class, and here you can't see it, but I have a say hello method, okay, in this current class that matches that signature. So, but I can still use the same interface C and the interface call to invoke the currently assigned method to my interface. It's pretty powerful. You can change out implementation. You can change out the functions of an interface. Okay, hopefully that wasn't too confusing, just confusing enough. So let's assign our method to our interface callable, and you can do this all in one line. I can create the instance, okay, and just invoke the method in one line. I mean, I should say I can assign the method in one line and then invoke it in this next line. So this is just less code. I could do it all at once. So this is the same thing as the previous slides, but just all in one line. Okay, I know what you're saying. You gave me a lot. I kind of understood it, but what was the point of all that? That was just like a wild, crazy clown show, but I don't see the point. Hold on, all right? You needed this kind of framework and background so that when we talk about streams, it'll make sense. Because if I skip all this and talk about streams, it looks like magic because, I don't know, maybe it is magically made by elves. But you need this basis to talk about the streams API and how Java is using lambdas in its API. So go back to these slides, kind of follow through it, but hold on, there's a reason why we went through all this. Primarily is to, when we go talk about the streams API, this is going to make a whole lot more sense. Thanks for sticking with me. Let's go on to the next topic.
Bajaría sin pensarlo dos veces.